see a few people still walking in, but let's go ahead and get started. My name's Abram Jackson. I'm so excited to see so many of you here today. Looks like we've got a packed house. Sorry about that there's not a lot of seating, but very excited to see you here anyway. We've got more sessions coming up where you can ask us more questions and where you can get more detail about some of these things if you can't find a seat today. I'm here with my colleagues, Dmitry Sarkisov and Greg Thiel, who is graciously sitting on the floor so that one more of you has a seat. How was that party last night? Anyone have any fun? Yeah, I was having a great time. But there's nothing funny about high availability. So some of you guys may not be on Exchange Server 2013 yet, and I feel bad for you. You're really missing out. We've got so much new in 2013 that wasn't in 2010 and earlier versions. So in 2010, databases recover themselves when you put them in a database availability group. But in 2013, your services recover themselves, your servers recover themselves. Heck, you can set it up so that your data centers recover themselves, and so that your job becomes a lot easier. Also in Exchange Server 2013, we've reduced the database failover time by 50%. Most database failovers are now less than 15 seconds, and no one really notices. And the other thing is we've got 58% faster reseeds if you use multiple databases per volume. And a lot of this is made possible by the new server architecture in Exchange 2013. I hope you heard Ross yesterday talking about the consolidation of server roles. And I just wanted to emphasize the point where with managed availability, we have all of these protocols running on your mailbox server where the active database is. And what MA allows us to do then is to recover the services, or if it can't be recovered, to move away the databases so that your clients don't have any impact, you're not getting help desk phone calls, your pager isn't going off, and you don't have to go fix things, where you can just come in the next morning and repair whatever was broken. So, maybe you've been wondering what we've been doing since RTM, since the last MEC. We've been doing quite a lot, actually. We've had more than 600 check-ins, and this is from like automated crash reports that you guys are sending in. We fix those bugs. We improve our test cases. We scale and stress, and lots of new features. So some of the features that we're going to be talking about today are DAGs without cluster administrative access points, the DAG management service, and you can see them all there. We'll be going into these in detail so that you can so you know how they work. So, it's no fun. I think probably most of us are on somewhere in the support chain. Maybe you're directly getting user phone calls for small companies, or there's Tier 1 support. Well, in Exchange Online, we don't have Tier 1 support. When I'm on call, which is for a week every few months, I'm the one that's getting these phone calls from the service when things break. There's no people to handle it for me. And for our developers, it's the same case. And so we are so motivated to make the product more robust, more scalable, and more highly available. And we do that in 4 major ways. One advantage we have of having the code base is that we can investigate and fix the root cause, whatever that is. But at the same time, the high availability solution we do all we can so that clients aren't impacted. And so we recover the user experience at the utmost priority, and we do most of that through managed availability, although, of course, site resilience and database availability groups play into that just as well. We have to repair the symptom, and fortunately, since we've already recovered the client experience, this can be done the next day or the next week, especially if it's something like hardware failure. And finally, another advantage that we do in the service and with our developers is that we remove complexity so that the thing doesn't cause more problems down the road and we'll have to spend more time investigating it and fixing more root causes. So in some cases, we can just remove what the problem was. So, our first feature, Microsoft Exchange Server 2013 Database Availability Groups without Cluster Administrative Access Points. This is, I put up a poll on Yammer, and you guys are totally free to continue to vote for what your favorite feature is that we talk about today. And this was the clear winner. And I was a little bit surprised because it wasn't a lot of work. But what we did is we saw that we were frequently, our on-call engineers, myself, our developers, were having to go fix cluster resources. Either the network hadn't been set up quite correctly or something had failed and it was causing problems down the line. And it's really boring and not interesting and not fun. So we go from this part over here on the right, where there's lots of cluster resources. You've got the cluster network name, you've got all sorts of IP address resources, and depending on how many votes you have a file share witness. And so we've removed all of that complexity except for the file share witness. So if you want to use this feature, you need a new DAG, and it's opt-in. You set your DAG IP addresses to system.net.ipaddress.none, or you can use 255.255.255.255 in the access control panel. And you can still manage your cluster using Remote PowerShell. Windows Server 2012 and 2012 R2 have very robust PowerShell commands to manage the cluster. But hopefully, in most cases, unless you're Tim, you don't have to manage cluster environments yourself. In most cases, you should let Exchange manage the cluster environment for you using stopdag or stop database availability group, restore dag, start dag, and those command lists that we give you. And Tim has that excellent PowerPoint to walk you through it. The DAG management service I've been getting a lot of questions about. It's not dramatically exciting, but you're going to see it on your Service Pack 1 servers. Really what we did was we just took some of the features that we had inside MS Exchange REPL, which wasn't actually replicating data, and we moved them out into a separate service. Because replicating data is so important to high availability that if something crashes or something goes wrong, especially in these newer features that aren't time critical, they don't cause problems for your data replication. And so I think you guys can all agree that if the MS Exchange replication service isn't running, you're having a bad day. And if it's not running in the service, I'm having a bad day. And so as we add these features and continuously iterate, we're very careful, but in some cases, at scale, there are some problems. This also allows us to use managed availability to restart just a subset of the services that are possibly causing a problem. Loose truncation is another really cool feature. I'm really excited about it. What happens with loose truncation, and we saw in the service, is that if a server fails or a disk fails, and you don't get to it right away, maybe you didn't quite figure out what was wrong, you thought it was your storage controller, and it turned out to be the motherboard or some other problem. Sometimes it can take several days, even into weeks, even up to multiple weeks, to fix your server. And normally when a database copy fails in a database availability group, the rest of the copies of the database keep around the truncation logs so that when that copy comes back up, if it wasn't a failed disk, if it was something else that was failed, we can reseed all of the logs automatically and just bring it back up. And you'll see that the database copy is resynchronizing, and everything will come back up, and you won't have lost anything. However, if you're getting into multiple weeks and you've got fairly high load on your database, your transaction logs are going to start really piling up on your other servers. And when they pile up, you're going to run out of disk space. When we run out of disk space, we can't write any more transaction logs. If we can't write any more transaction logs, we dismount the database. And when the database dismounts, my phone starts ringing, or your phone starts ringing. And a recurring theme, I think, throughout this talk is that I don't want my phone to ring. It's a really annoying ringer, not quite as annoying as Greg's ringer, but it's still really bad. So what I showed here with active loose truncation, I'm going to have to move over to the keyboard, I think. So instead of allowing these other copies to fail, we just remove the transaction logs that would otherwise be necessary on this fourth copy. And so what that does is that when that fourth server comes back up, that copy is going to be failed and suspended, and hopefully you've set up auto reseed so that it's repaired that way instead, but the database never dismounted. Similarly, passive loose truncation works slightly differently. So if this server is out of space, perhaps one of your other servers has just a little bit less space, and we saw this is something that we learned in this service and we had to add. If this other server runs out of space, we can just remove the transaction logs that it has first, instead of changing the global truncation number all the way up and removing the logs from all of the copies. Another feature that we've delivered in Exchange Server 2013 that's pretty useful for us. So several months ago, two of our data centers lost contact to the rest of their data centers that hosted copies of their database. And this was it's a scenario that we had planned for, but it was something that it was still very difficult because we hadn't seen it before. And so since we lost 2 copies of our database, we only had 2 copies of these particular databases left. And when we get down to just 2 copies of our databases, we start getting really worried. But even worse, one of those copies was the legged copy. And so since the legged copy is going to take time to replay and get back and become healthy, there's only really one available copy left for some of these databases. And that makes us really nervous, because if that disk were to fail, if that server were to fail, our phones start ringing. We have dismounted databases again, while the leg plays forward for maybe 12, maybe 24, maybe 48 hours. Right? That's a very long outage in our service, even if it's just for 1 or 2 databases. So what we added for our leg database copies, and this is one of the services that runs in the DAG management service, is if there's only one available copy of your database, we just immediately start playing forward that leg database copy so that it becomes available. We don't have to go through and look at all of our databases and make sure that the legged copies are playing forward, so that it becomes available, and when the disk fails, it just fails over. And again, we're only in 1 copy, but this time we're looking at a triple failure, and hopefully that's going to be pretty rare, and we won't see that 4th failure. There's a couple other scenarios where we need to play forward the leg a little bit. One's running out of disk space. If your leg database copy runs out of disk space, it's going to dismount, and now it's no longer a point-in-time backup. So instead of doing that, we'll play forward just to the part so that we can keep the maximum amount of your point-in-time backup as possible, and that might come back to 5 days if you've configured it to more, or some other value. The other one is if the disk causes a bad page in the database. Again, it's not a point-in-time backup unless you can restore it. And so since you can't restore through this bad page, and the other copies of the database don't have that page because it's at a different point in time, we need to play forward the leg to that point in time and page over the patch. And hopefully that was still several days ago, but at least it is still available. All right, time for my favorite feature. This feature directly replaced a couple people that we had reseeding databases and changing mount points. So I'm glad that I don't have to do it anymore. But let me just tell you the basics of auto reseed. Basically, you set up your server with your volumes configured into the Exchange volumes directory. You add a spare volume or 2, and then you just wait. So if one of your database copies fails, auto reseed will take a mount point from one of the spares, bring it over to where that mount point of the failed volume was, and then reseed the database from the active copy. So let me show you how that works. So in this test topology, I've got NeatDB1 and NeatDB2, and they're on the same volume. I actually need to check which volume they're on. I'll show you. You can see here that they're on the mount point Exchange volume 2. So I'm just going to go ahead and offline that volume so that Exchange can't read it and Exchange doesn't know where it went. You can see here that set broken was called, which basically just makes the database's copies failed and suspended. So they're failed. So AutoReseed is going to take care of these. And I'll come back to this demo in a minute when it's able to finish. So why did we build AutoReseed? And we'll come back to that demo, don't worry. I'll show you that it worked. And you can cross your fingers for me. So we built AutoReseed to directly replace the operators that we had reseeding databases, because again, it's really boring, and we don't want you guys to have to do that either, right? The real intention is that you no longer have to pay attention to when one of your disks fails. You don't have to wait for your disk to fail and then cut a ticket and then go have someone, or possibly yourself, go replace that volume. Instead, you set up a recurring maintenance of just looking for all of the failed disks in your environment, in your closet, in your data center, and just replace them all. And AutoReseed takes care of the rest. I've got this chart here of how robust AutoReseed is. In the service, it succeeds 99.94% of the time. So even though we have thousands and thousands and thousands of volumes, we haven't had to do a reseed for months. The few times that it does fail, it's because we ran out of spares on that server. And even then, right, you've only lost one of your database copies, so you can go ahead and wait. You can wait for that disk to be replaced, set up the volumes, and then AutoReseed will take care of it for you. And this makes our jobs so much easier. Or if you remember the video from yesterday, it's not easier, but it's more fun, and you can have dance parties in your server closet. I've got an Excel formula here of just looking at, independent failure events. But you'll see that if you have one spare volume per 10 database volumes on all your servers, you won't have to replace your volumes more than about monthly. And if you want to do yearly, you can just add a few more spares and then replace your disks every January 1st. That'll work. In SP1, we've continued investing in helping you out with your storage subsystem. And if your storage subsystem hangs, the only way to recover it is to, maybe reseat your controller or something like that. But usually, you just hit the power button. So what we've done in 2013 and in Service Pack 1 particularly is waiting for creating monitors and responders in the managed availability pipeline that Dimitri's about to talk about, to just bug check the server, because that's what you'd have to go do anyway. If you notice the storage subsystem is hung, you'd walk over it and hit the power button. We'll just take care of that for you. All right, let's check out how AutoReseed is done. So I'm just looking at some of the Crimson events here. This just dumps out our Crimson events. Okay, looks like it has successfully initiated a reseed. Seeding has begun. It's got logs. Okay, let's see how we did. One of them is resynchronizing, and the other one's about to come up. The reason that one of them is not yet recovered is because we used the first database that failed to remap the mount points, and that hit one of the retries of AutoReseed on the second database, and it will come up in a couple minutes. If you guys want to call me on it, you can ask me a question at the end, and we'll see if it's healthy. And I almost promise that it will. So, I love my job. I hope you guys love your job. But what I really love about my job is that we're working at such scale. And this is so interesting for high availability and storage, because you get the economies of scale. You're able to work on your data, your insights into your data. And it's always new problems, always new challenges. And we have the talented engineers to be able to go look at it. And it's so cool. So I'm going to tell you a few of the secrets and how we run our data center. So we have more than 125,000 databases, and you can guess how many. You can figure out the minimum number of DAGs that requires, but it's a good number of DAGs as well. Our average database failover time 15 seconds, sometimes 16 seconds, but we see this measuring thousands and thousands of database failovers, that they are averaging 15 seconds. The other really cool part about site resilience, and Greg's going to talk to you more about site resilience, is just how often it happens when you get to a scale this large and how well you've got to improve your features. And Greg's going to talk about some of these features that allow us to do this. But last month, I think we did more than 700 device maintenance, including site switchover. So that's failing over all the databases to another site, repairing the maintenance, no client impact, nobody notices. And we also have tens of events every month that are unplanned. Something fails, and we need to recover. And we do that while keeping 99.98% database availability. So these site resilience events, they happen a lot, and we're getting very good at it. And you can be very good at it in Exchange Server 2013 SP1 in the same way. We've got something like 26 different locations worldwide with our databases in them. And so this allows us to have very good availability, to allow our databases to move all over, and for us to be able to be this good at site resilience. I'm going to explain this chart on the bottom left. We call this our 1 copy minutes chart. And so we've been tracking this. Dimitri's been tracking this for a couple of years. You can see that it goes back to February of 2010, where what this number means is for every database, this is the amount of time that it spent in one redundant copy. So while a database is in one redundant copy, the wrong disk failure or the wrong server failure means that you've lost your last copy of your data. And in most cases, this would mean that we would have to mount our stale copy, a stale copy of the data, which is missing maybe a few hours, maybe just a few minutes of that data. And so we've been trending down per database, which we have to do because increasing your scale increases the amount of things that can fail. So we've got 125,000 databases, and we need to keep bringing this lower and lower and lower, or we'll hit one of our databases that are actually in one copy for a significant time, and we'll lose it. So we're trending this downward. We're down to just about 0.01 minutes per month, which I lost track of how many nines that is, but I think it's past 5, right? 6? 5 or 6. And so that's one of our major focuses of our team, is keeping our databases redundant. This other chart is the managed availability recovery actions that HA does. And you can see here that the service restarts are up at the top. We're just fixing things for you. The top one is 0.1 times per server per week. And we think that's a little bit too high, and so we're investigating it. But some of these other things, we're just restarting the service, and it recovers the problem. If it didn't recover the problem, these next things would be firing. And so all of the deltas you see here are pages that I didn't get, and hopefully the pages that you're not going to get. We also do, of course, server failovers, and we bug check the server if everything is just totally and completely hung. Well, now I'd like to introduce my colleague, Dmitry Sarkisov. He's our test lead. He's going to talk to you about how we've been improving monitoring in Service Pack 1, and also the best way and the recommended way to do maintenance.
Good morning, ladies and gentlemen. My name is Dmitry Sarkisov. I'm with Abram and Greg, representing high availability team. And today I'm going to talk about managed availability in the context of HA. Before I start, let me ask you a question. How many of you consider yourself experts in, or close to that, in managed availability? Okay, great. You guys are going to keep me honest during my presentation. For the rest of you, well, I wish I could tell you that I can turn you into expert in 15 minutes, but it's unlikely to happen. But at least my goal today is to ignite your interest or reignite your interest in managed availability and deliver the message that we effectively live by of how important and how great this feature or framework is and how much goodness you can derive from that if you embrace it. So, managed availability. It's a framework that is designed to detect customer degradation in the system, to attempt to recover from the failures, and if the recovery failed, to escalate to Exchange administrator. That's being, in case of on-prem development, on-prem deployment, you guys, and in case of the Office 365, that's us, engineering teams. It's easy to think of managed availability from the high altitude as three asynchronously running engines. First engine is a probe engine. Basically, probes are all kinds of measurements of perception of customer experience, all kinds of shapes and forms. And the data that is collected by probes is fed into a second engine, which is monitor engine. And I would say this is the central part of the managed availability. It's brains, if you will. That's basically where the correlation of all the results happening and the decision about changing or not changing the state of the monitor is made. Now, based on some transition of the states of the monitor, going from healthy to unhealthy in some case, we engage the third engine, the responder engine. Think of it as an executive branch of the managed availability. It just acts. There is no complex logic in it. We just try to recover service if we arrive to that point. The list of the responders is quite short. These are effectively the actions that we decidedly implemented to recover service in certain scenarios while we do not cause any downstream negative impact on the server. And going from mild towards more drastic measures, they are reset application pool. The next one is restart service. We may even restart service twice. We do believe that that helps. Trust me, it does help. Next, failover. Again, we can failover a database or we can failover entire server. The last automatic recovery responder is rebooting the server. But that is not the last responder in the list. The last responder is escalate responder. So at that point, we tried certain things. Unfortunately, we fail, and we're just telling you guys, please come and take a look. The system is still unhealthy. Somebody needs to take a look at it. As you can imagine, there are great many monitors, simply because Exchange developers love their customers, and they try to cover every conceivable scenario. And that's true nowadays, in SP1 in particular. Well, on the flip side of that, unfortunately, most of you guys, Exchange administrators, need to deal with that variety. Well, things are not that bad. There are a couple of commandlets, and I'm going to show them in my demo, that certainly help in this context. First is get server health. Simply, if you run it against a particular server, it will dump the output of all monitor states. And that's going to be a long list. You probably don't want to do that too often. The rule of thumb is probably you either want to filter it against monitors that are in unhealthy state, or you focus on health sets. Think of the health sets as a group of monitors that are logically aggregated around certain customer scenario or a certain feature, something like this. And the second commandlet I would like to mention is get health report. That's the view on the system from even higher altitude. So if the first one was producing the output of the monitors, the second one is a roll-up of the outputs. Effectively, it's the list of the health states. And again, even that list on the mailbox server is quite long, and it probably makes sense to filter unhealthy health sets. Finally, when, and I'm not saying if, when you are experts in managed availability, you probably want to dig even deeper into the inner wiring of probes, monitors, and responders. And the first step is probably to go and look at their definitions. There are things like throttling and time transition that you can learn from that. And all definitions of probes, responders, and monitors are in the Windows Crimson channel. And again, I'm going to quickly show it to you. And by the way, the Commandlets are in the notes of the demo, so you can try them at your will whenever. Now, HA managed availability. We use managed availability to keep track on data redundancy, cluster health, storage health, and the special cases, logical data corruption, logical database corruption. God forbid it happens. HA probes and monitors are grouped into two health sets. It's clustering and data protection. And here we are. This is the slide that presumably should show all of them. Before I display them, I want to say there are quite a few of them, so it totally makes sense to talk in terms of grouping. So the first group is the clustering health set. It's rather small. The second health set is the data protection, and it's the big one. So I broke it into a few subgroups, which are covering, in this case, this is the set of monitors that there is looking at the server health. Next is the database level, database copy level. This set is for database corruption. And last couple monitors are for storage health. By the way, the monitors in bold letters are those that we added in SP1, and as you can see, we added quite a bit, and usually that comes from our experience in data center. That's where our pain points are, and that's how we try to eliminate them, to recover. Now, I have to say that we love our monitors all equally. They all are equal to us, but some are more equal than the others. There are a couple of them in that context that I would like to focus on a little bit more today: one copy monitor and REPL endpoint monitor. First, one copy monitor. Arguably the most important monitor HA has in its arsenal. It's been serving us pretty well for a long time. It's been paging us, that's true, but for good reason. We learned a lot, we adjusted it, we adapted it, and whenever it fires, it's a real deal nowadays. So how does it work? As Abram already mentioned, one copy means we don't have a passive copy to fail over to. So we just end up with just one mounted copy. That usually does not mean that one server just went in flames and somebody dropped a sledgehammer on another data drive. That usually doesn't happen. You don't lose copies, but they become unavailable. And as Abram mentioned earlier, they're getting stale. And there are pretty strict rules for us, which we follow to treat database copy as healthy or otherwise in the context of redundancy. So first of all, the copy must be healthy or mounted in order to be considered as a redundant, sufficiently redundant copy. A server that hosts this copy should not be in offline mode, or it should be online. In other words, database copy should not be suspended. It's either server should not be suspended or copy individually. Server should not have server should not have more active than max active on the box. Then, if I'm not missing anything, it's the copy queue should not be greater than mount dial, so we can mount this copy. And the last item we added in SP1, that's about server being activation disabled. That's a new parameter. Mailbox database activation disable and move now. When it's set, we fan out all actives immediately from that server. So when either of these fails, we detect it. And if we detect 30 consecutive failures of the kind, we send notification from the DAG management service to the monitoring, to the managed availability, and the monitor turns unhealthy, and it immediately engages one copy escalate responder. Now, in this case, we don't have any recovery responders, at least not yet. But that doesn't mean that we do not try to recover. The truth is that our recovery methods, and by the way, one of the slides from Abram showed them, like we can bug check the server if we see the storage stack hang, or we can restart replication server, or we can move PAM. So we try certain things, but those are built in within replication service. And again, it's older than managed availability. So we built in a lot of stuff already in it before managed availability arrived. So at this day and age, when we tried everything and for the 30 minutes, we see that the database is in one copy, we do escalate. The second monitor I would like to focus on today is, it has very long name. I'll call it REPL Endpoint Monitor. So basically, it tells us if the REPL is unhealthy in some way or form, and that's why I actually brought this up. It's interesting because it has three probes for three endpoints, for RPC, for TCP, and for server locator. 3 channels that could fail. Each of them could trigger a chain of recovery actions. And there are quite a few of them too for this monitor. So first, when we detect the failure, we restart service, and we do it again. And it helps sometimes. If that doesn't help, we fail over. If that doesn't help, we reboot the server. And then if that doesn't help, yes, we escalate, unfortunately. Now, the conversation about or introduction into managed availability would be somewhat incomplete if I didn't mention how do you put server in maintenance mode nowadays to prevent all the bad things happening to a customer as well as to the Exchange administrators. So the story in 2013 is a little bit more complicated than in 2010, simply because we have more roles on the box. Mailbox now has mailbox role, transport role, and it may even have a cafe role on it. So in order to prevent the outages, you need to follow certain steps. The good thing is that those steps are pretty well established, and in terms of running commandlets, again, I have an example in the demo and example in the notes. They're pretty straightforward. So first of all, you have to drain transport queue and unified messaging queues. Then you set messaging redirection after you drain the queues. Then you set your you suspend cluster node to prevent that node from becoming a primary active manager. Then you set activation disable that causes databases to fail over from that server immediately, if there are any at this point. Set activation blocked to prevent databases failing back to that server at any point. And finally, we set all component state offline. That effectively disables all protocols, disables transport, and it is safe now to take server offline, power it off, do whatever you think is necessary to do to recover the hardware. And there are a couple of commandlets to obviously confirm that is been in fact done. And again, I'll try to show it in a demo right now. Let's see how much luck I have. Oh, okay. Let's see. So this is our test environment. And I have a few commandlets already pre-written, so I'm going to run them in a bunch because I really don't have much time. And these commandlets are easy to run. They are non-invasive and carry a lot of information. So first of all, about how do we evaluate health of the server. I just ran get server health with the health set data protection. And as you can see, it only displays that many monitors. One of them is, and by the way, one of them is unhealthy, and I might guess I know why, because I didn't set circular logging on my on one of my test databases. That explains why. Now, get health report it shows you the output of all the health sets for the server, and the second command is for a DAG. Now, next item. I really want to show you how you can play around with the probes, monitors, and responders with their definition in PowerShell. I know my demo is probably the most boring among all of them. I mean, it's just PowerShell, but trust me, there's a lot of value in it. Oops. One more time. All right, so I'm collecting all the definitions of probes, responders, and monitors. And to give you an example how I can use it, I pivot probes and responders against MS Exchange REPL endpoint. And if I filtered probes by name, I can find all the probes. And obviously, that's just a short version of what's in the definition. The same way I filter responders by alert mask, I believe. And here we are. Restart second trial, failover, reboot, and escalate. Finally, I can look at the monitor itself, this one, specifically at this parameter, state transition XML. And that will tell me at which point each of these 5 will go off. And the interesting thing here I wanted to show you that I actually applied overrides. It's possible. You can tweak your system. If you don't like the default parameters, like for example, in my case, I needed to restart service immediately. I changed this timeout from, I believe it's 3 minutes, I changed it into 0, so it goes immediately. And for example, the restart second time goes in 55 seconds as opposed to, I believe, 6 minutes in the default environment. So now, let me actually start doing real demo. So this is an internal debugging tool. It's easier for me to show this one as opposed to jumping between different channels in the event log and looking for the events. They are already preset to filter probes, probes, monitor, and responder changes when I'm going to trigger REPL endpoint monitor. So in order to do that, I'll just stop REPL service. That's it. And see what happens. But before, I need to... nobody reminded me. There you go. Let's wait for a first probe to show up. So this is the monitor. And I'm waiting for probes. So everything is good. Probes are succeeding. Monitor is healthy. Now I'm going to hit the button and stop replication service. Let's see what happens here. It's, as I said, it's a synchronous engine. Nothing is going to happen immediately. In fact, if it happened, your CPU would be probably draining a lot of power into the service. So we do introduce timeouts. As you can see, the probes already started fail. Oh, there's the one. The first one failed. So in a few seconds, you should see the monitor going into, I believe it's going to be degraded. But let's see. There you go. We are in a degraded state. And right away, because I set the timing transition to 0, the responder kicked in immediately. As opposed to in the default environment, it would take 3 minutes. Now, let's see if the service is actually restarted. Yep. Booyah! It's running! Thank you. That's not it. There is one more quick one. By the way, as you can see, the probes are now succeeding. Monitor is still degraded, but give it a few seconds. There you go. Healthy. By the way, to make sure that you don't have to trust me with this magical UI, I can show you one of the events. Recovery action results. This is the event. It's 9:31 right now, 9:30:09. That's when the Restart server responder kicked in, and it was successful, and it restarted the service. This is what you probably need to look at and collect those events over time. Because as Abram showed in one of his last slides, it's totally worth to know what recovery is doing for you. It's great that you're not getting paged, you're not getting calls, but managed availability is so powerful that it could hide issues in your system. So those kind of things you probably want to look at with some periodicity. Now, the second demo I wanted to show you is one copy monitor. Now, in order to actually show you live one copy monitor, I would either have to hack REPL service or actually DAG management service or wait for 30 minutes. I cannot do either. So instead I hack notification. I'm gonna run my own script that sends a notification to monitor system. Again, I need to turn this thing on. Right, it's running. One copy monitor doesn't have any probe because that's a notification. It's coming directly from DAG management, directly to monitoring. So what I'm going to do now, I'm going to call this little script called red, brilliantly named. And as you can see, the monitor turned unhealthy, as I promised, right away. And we engaged the escalate responder. Now, again, sorry, to show you what to look at in this case, because it's not recovered. Yes, we detected that we have one copy, but unfortunately we cannot do anything about it. What you need to do in this case, probably in the first place, is to check monitoring Crimson channel and there, no, here. Okay, let me try one more time. There it is. So when data protection health set goes to unhealthy, it publishes this failure event. And what is important here, this is what I want you to focus on, it tells you precisely what is going wrong. It effectively is saying, I'm sorry, I couldn't recover it for you. But here's the next best thing. You know exactly what went wrong. And that's almost it. Let me just finish this with recovering. This is a green event telling the monitoring system that database now in a good state. So there it is, healthy. And finally, I wanted to show you, as I promised, I wanted to show you what do you actually run in order to put server in the maintenance mode. Here's the list of commands. I know I'm running out of time. Sorry, Greg. Real quick. There you go. So we start with, too fast. Over here. We start draining transport, draining unified messaging. Technically, I should wait between the second and third line before transport server kicked in. And then I redirect messaging from server that I want to put in maintenance to another server in that same DAG. After that, I suspend cluster node. After that, I set this new parameter that we introduced in SP1, database copy activation, disable and move now. If there were any active databases on the server at the time, they would move out. After that, copy activation policy blocked, so no databases can be mounted on this server. And finally, I set server component state server wide offline. After that step, all the protocols are shut down on the server, disabled, however you like to call it, except for monitoring. Now, this is already checks, so all components are inactive, which is good. Activation is blocked, disabled, true, server is paused, and copy queues are at 0. So server is ready to be taken down. That's pretty much a message that I want to try to deliver today. Please try to. Now that's a signal, and yes, I'm almost done. Anyway, guys, enjoy managed availability. All I can say, it's a great thing. It's going to help you. It's going to make your life much better. Thank you. Thank you very much.
My name's Greg Thiel. I'm PM Architect on Exchange. What are the buttons here that I push? Dimitri, which button did you push? Thank you. So let's start by talking about best copy selection. There's been some dialogue about it a little bit already, but let's talk some more. So best copy selection in 2013 expanded a little bit because of the architecture of 2013. Ross Smith in the architecture session told you that protocols are now running on mailbox servers. That means, as he said, and as I think Dimitri said a bit ago, that if a protocol is unhealthy and there are active databases on that server, those users are not getting service through that protocol. So Outlook is offline on a given server. You have databases active on that server, no Outlook for those users. The best copy selection is still an active manager-based algorithm. It's still running at the time you run the failover or the switchover. It's still going out at that time and collecting the health of the environment. It's collecting the protocol health now. It's also collecting, copy queues, database copy health, all of that information, pulling it back to the PAM and running on the PAM to decide which copy to pick. The basic criteria of catalogs versus copy queues versus the various other phases of BCS really haven't fundamentally changed in 2013 SP1. We've done a couple of tweaks. We'll talk about some of that. So some of the stuff that's new is in the service we started finding cases where we would activate a copy with a large queue, okay? A large replay queue, a large copy queue. That turns out in the earlier versions of Exchange 2013 or 2010 to be a bad idea because interrupting the mount was hard and it might run for an hour and a half. If the cause was, hey, a server bug checked, 10 minutes later the server's back up and ready to take service, spending an hour and a half replaying logs wasn't the best experience. So we capped the limit. The limit is now 400 logs, the sum of the copy queue plus the replay queue. That makes the mount time manageable. It isn't like you're going to cause an outage because the copy that's over that limit is going to play down. We're going to periodically try to do the failover again, and eventually it'll be under 400 and we'll mount it if there was no other copy that qualified prior to that. There's the new limit around max soft limit for max actives. We'll talk about that in a bit. That's trying to give better distribution of databases in the face of a few servers failure. The BCS criteria around protocol health, I have a slide on that. We'll go through that. But again, that's about trying to find the best place to put active copies when you consider the fact that database copies on servers with unhealthy protocols correspond to an outage. In general, there is a slight difference that we'll dig into in a future slide around the MA failover responder asking for a failover versus, say, a server dying. The reality here is that what we're trying to do with the MA failover is restore service for a protocol. So going someplace that isn't as good, doesn't restore service, doesn't prove anything. So these are kinds of things that are different. We'll come back to and talk to most of them. Activation controls, there are 3 different scopes that we do today. One is load management, like, hey, I don't want more than this number of databases active on that server. That directly corresponds to how much CPU that server is using. The next one is server level. You saw in Dimitri's maintenance mode, he was using server level flags to control whether a given server had active databases on it. We'll talk in more detail about those flags. And then there's the one that people probably don't think much about, but is the database level activation control, What this is really targeted for is, say, when you have a disk that you don't have confidence in, it's throwing errors, you would prefer that it not host an active database, but you know you're willing to have it be a passive until you can get it switched out. Well, you can set it at database level activation suspended. It'll stay passive. It won't become active. You won't have the risk of maybe having the disk die when it's active. So this is going to talk to load management limits. Look, there are basically 3 points in this spectrum that we commonly talk about. The one on the left is the optimum design. All the servers are up. You've got even distribution of active databases across that server. That's typically the result of running redistribute against the DAG. Balancing that out, getting all the servers to be hosting as active their preference 1 database copies. On the other end of the spectrum, the right side, is the maximum active databases. This is your ability, the control of how much load you will bring to this server in any worst case scenario, or any scenario actually. And this gets set as basically a configuration point in your environment. In the middle is the new guy. He's the max preferred actives, and what he's trying to do is get better distribution in the face of 1 or 2 servers being failed in a day. What we saw in the service is when we had those cases, we could easily get servers that were near max actives and other servers that were near 0. Then we put in max preferred actives. What we see now is in this situation, the databases are nearly perfectly balanced. So it's going after giving you good experience on all the servers, precluding that you see high peaks in particular servers. It's uniform usage of the servers available. Let's dig a little deeper into the 2 flags. Max preferred actives is your hard limit. You set it based on what's in the calculator. The calculator gives you, a number for that. I should have said back here, the example across the bottom of 14, 19, and 28 is for a 16-node DAG, 14 disks, 4 databases per disk, configuration with 1 spare disk. The 28 is what this calculator will spit out. Evenly distributed is 14. Max preferred would be around 19. So BCS is the guy that's enforcing max actives. He's doing that by making sure that he doesn't try to make a database active on a server that already has max active number of databases. What will happen if all the copies are either unhealthy or healthy on servers with max actives, the database won't move. We have nowhere to put it. We're not going to force it someplace to exceed max actives, and we're not going to do some kind of redistribute on the guy that's hit at max actives that could mount the database. So you're going to see a dismounted database, a database that doesn't move. We will periodically retry to move that database if it is dismounted, but it's going to not move or go to a node that's exceeding max actives. Max preferred actives, this soft limit we added in SP1, works by basically having a little tweak in BCS. So what it does is say, if this server is at max actives or above, then I would prefer not to pick this copy. Let me try some other copies, see whether some copies with an unhealthy catalog or something else that would pop at the lower level in the phases of BCS can get the copy mounted on a different server rather than this server that would exceed max preferred actives. So that's what it's doing, and it's giving you a better distribution. If you don't want, if for some reason you want to get past these limits, there's an option on Move to do that. Okay, and you can read it, skip maximum active database checks. We talked about protocol health. These are the 2 cases around protocol health. They may not be obvious, but I think when you sit and look at them in this context, they'll make sense to you. There are 2 different scenarios I mentioned earlier. I have a server failure or a database failure. I need to fail that guy over. Okay? Versus the other scenario is I'm a given protocol. I'm failed on this server. I want the active databases off this guy because I'm trying to restore service for that protocol. In that case, you have a very specific desire. You're trying to get to someplace better. Whereas the first case, the normal failover, You're just trying to go the best place you can go. And so going through the normal scenario case first, we try to find a copy that has all health sets I can't say that. All health sets healthy. And basically, it's not every one that Dimitri put up there. If you go dump all the health sets on a mailbox server, it's a long list. But what we look at is there's certain health sets, typically one per protocol, that's marked, is HA impacting in its definition. Those are the guys that we're looking at for this. And we're looking to find all of them healthy. We also prioritize the health sets, so the protocols are prioritized. For people that love POP, I'm sorry, it's medium priority. For Outlook, OA, and EWS, they're high priority. I think you guys can all understand why. We are trying to service the most critical priority protocols to the users in preference to the second tier and third tier protocols. So the second check is medium above are healthy. Third check is saying, hey, is that guy better than I am? And the fourth check is saying, is he equal to me? And if I can't match any of those four, then I'm in desperation mode. Please find me a copy I can go to. Because after all, the server's down, the copy's dismounted because the disk is dead. So that's that side. On the MA failover side, the first check is really to see, is it better than me? There is no point in going someplace where the protocol that you're trying to recover is unhealthy. No point in all. So if the target isn't better, he's crossed off immediately. And then you go through the first three that I went through the other side. Are all the health sets healthy? Are the medium and better ones healthy? And is it better than I am? It can't be equal to me because the first check precluded that. If it's equal to me, then my protocol is just as bad. Let's talk some more about site resilience. Dimitri kind of spilled the beans about database disable and move now, but let's go and talk about it in a little more detail about its behavior. This has really helped us in site resilience because what it's fundamentally doing is getting databases off this server as fast as it possibly can and keeping them off if it can't get them all off immediately or if some come back. So basically, we set this bit. It's set on the mailbox server object. It immediately, in parallel, tries to move all the databases off that server. And then, if it can't, because there's no other place for a database to go, it will leave it. But every 2 minutes or so, it comes back, looks for active databases, and moves them off again. And when you're in a site resilience scenario, what happens is databases can come back, okay, because they take a failure in your primary, in the data center that's still standing, so to speak. In the service, one of the things we do is we will not fail back until the peak period ends. So most of the time, we're switched over for multiple hours, even though the outage might be an hour. This really helps us because, hey, we can still use that data center that went offline, independent of its failure, during the remaining multiple hour window as we wait for peak to succeed. Chances are you guys in site resilient events are going to make the same choice. If you've just had a multi-hour outage, you're going to fix the issue after the switch over. You're not going to immediately schedule the switch back. You're just adding pain to your customers that are already pained. So you're going to wait till the end of peak, till you have confidence that the issue is restored. You're going to want the same behavior, that if you can't mount a database in the part of the world that you would prefer it be in, then it can come back into the switched out part. We will proactively move things out. One of the key things around this guy is you are still in service. These mailbox servers marked this way are still in service. They are not in maintenance. They will still take active load. If active databases come there, they're still doing mail transport functionality. So I've talked about a couple of different modes of activation management. I wanted to put a table up for the last two cases and just walk you through the differences because it's not all obvious to you. The first one is suspend mailbox database copy. This is really about handling the somewhat sick disk. It's a primary scenario there. Set mailbox server, database copy, auto activation policy blocked. That's been there for a while, I think since 2010. its usage primarily is one, maintenance mode, and two, to do active-passive site resilience. In active-passive site resilience, people don't want active databases in the backup data center. This will get that for them. You can explicitly move databases, but it requires explicit action of the administrator. Set mailbox server, database copy database copy activation disabled and moved now. We needed a longer name for that. We couldn't come up with one. It's what I talked about a bit ago, and it's really all about site resilience, keeping the databases off, moving them off quickly. So internally in Exchange, I get a lot of questions about, we're switched out of this site, why isn't it in maintenance mode? We've made site resilience look like maintenance mode to our engineering staff just because we found it was easier for them to grok. They were less overwhelmed by saying, hey, I'm going to put a rack or a site in maintenance than to say, oh, I'm going to do a business continuity switchover, a site switchover. Somehow that sounded massively more scary than, hey, I'm going to put a rack in maintenance. Abram put up that we do 700 some odd maintenance acts on network hardware. That's done by doing, rack maintenance operations, which is a site switchover for us. Maintenance mode is nothing active on that server. No databases, no PAM, no Mailflow. That's what that's about. You're installing software, you're fixing hardware, you have something bad on that server, you don't want it in service. That's what that's about. Site resilience is not that. Like I spoke to, we stay switched over long after the issue might be recovered in order to delay further impact to the user. And when it's switched over, the CAS is out of service, but not because we put servers in maintenance. It's out of service because it can't be reached anymore, right? The VIP is removed, something of that form. Mailbox servers are not out of service. Disable and move now allows databases to come back. They will get active. They will have transport mail to be delivered to them, assuming they're available. I mean, we're not obviously going to have a server that is offline because the network's down be in service. Dynamic Quorum is a Windows Server 2012 feature that allows quorum to be sustained in the face of node failures. And what you see here is basically if nodes go down, quorum stays, the votes are set to 0. Okay? Nodes come back, they join, they get their vote back. That is reducing, after the failures happen, it's reducing the number of votes in the DAG. That enhances the ability for the DAG to maintain quorum. It increases the frequency in which you stay up and survive failures. It's all goodness. It's reducing the amount of time you have to run restore DAG. Witness is basically, Dynamic Witness came out in R2. It was basically the clustering team realizing they could do the same trick on the witness that they did in 2012 on nodes. So dynamic quorum and DAGs, we aren't dynamic quorum aware. We use it in our 2012 configurations. It helps reduce the amount of time you're going to have to run restore DAG to restore quorum because the quorum is shrinking as part of dynamic DAG, increasing the probability that the next failure causes any kind of disruption to the DAG, or decreasing the chance that you get disruption to the DAG for the next failure. We use it on Office 365 for servers running on Windows Server 2012. We suggest you use it. It'll make your life better by reducing the occurrences of which you have to run restore DAG. The one caution I give you, and it's important that you pay attention, is if you run restore DAG, be careful to make sure that all the servers you stop are powered off and their BIOS setting doesn't allow them to power on. Without that, and using dynamic quorum, simple quorum math may trick you into believing that the stop nodes can't form quorum. That's not true. Witness Server 2013 choices, there's one more choice. The historical choices of, hey, you put it in the data center where you have all your servers, if you have only one data center configuration, still there. The 2 data center configuration, pick one to be primary, put it there. The case that comes up in 2013 is what I call the 2.5 site option, which Scott happens to hate the terminology, but I like it, because the point is that you can put the witness in a site that you wouldn't put Exchange servers in, but is well enough connected that it's failure independent from a network perspective to the other two locations. If you do that, then when you lose network connectivity between the two data centers, one of them will be able to reach the witness and keep the DAG up. So you will get automatic recovery. So on the site resilience side, there's two things in 2013 that I think translate to a major improvement in terms of the experience around site resilience. One is we made front end and back end be recovery independent. Front end breaks, recover it. Back end breaks, recover it. You don't have to do the other because the other one broke. So for example, if CAS breaks in 2010, you have to go fail over the back end because you don't get access without it. In 2013, that's not true. The multiple IP addresses for your namespace is another big win because most of the protocols in 2013 are HTTP based, and that stack will automatically fail over to the next IP address in the list if it can't do a TCP connect to the first guy on the list. That means your recovery time, your detection of an issue is irrelevant. Client sees an issue, he goes to the next guy in the list, and you're restored service automatically. You may not even notice a blip, but the client is still working. So that's a big win from a recoverability perspective. There's another big win to the multiple IP thing. One of the pain points with 2010 is you have to do a DNS update in order to restore service for the cafe servers. That's not necessarily the first priority in 2013. If you turn around and turn the VIP off, you will restore service for the user in all cases. Black failures where it's hard down, gray failures where it may be sporadically failing. Because you turn that VIP off, that multiple IP address returned in the DNS record is going to kick in, and you're going to see clients skip past the guy that's bad. Because the TCP failure, the TCP connect will fail. Big win. The namespace, because you're returning multiple IP address, no longer a single point of failure. You don't have to deal with DNS latency anymore. Still do the DNS update to remove the VIP, but go after turning that VIP off. Because you turn that VIP off, you're out of that data center, out of that array immediately. Ross talked about bounded and unbounded namespaces. I'm not going to take time to talk about this. Either choice can have multiple IP addresses. Use multiple IP addresses. Use the namespace that makes sense for you. The last slide is about best practices. The first thing I would say is, look, make your recovery steps be automated. I don't know how many times I've said internally that when site resilience events occur, significant ones, it seems like even the most talented people become idiots, myself included. I don't care how many times I've done it, the next time that comes along, something's different, my mood's different, I don't know, I forget something. Automate the thing. The other thing is keep it as simple as you possibly can in terms of decisions and steps to run. One step is better than two, two is better than 10. 0 is better than 1, by the way. Exercise it regularly. I don't care how many times you've tried it, try it again. Dimitri and the team did roughly 75 site resilience tests prior to shipping O365 RTM. Do you think we didn't find failures in the last 10? If you do, you're wrong. We hadn't changed the code, we tried it, we still found issues, whether it's because the configuration of the environment had tweaked or whatever. All of those can impact what happens. So try it regularly, have the discipline to try it. The last 2 points are related. People tend to focus on the recovery steps and forget the other 2 pieces of the time associated with site resilience recovery. That's detection and decision. We have seen cases where our recovery was 5 minutes and our decision and detection time was 2 hours. Okay? So you've got to make sure you get that part down too. It doesn't come for free. And so having a good understanding about what corresponds to what you consider a site resilient event and flagging that for people to understand, do this now, is important. The last bullet on this slide, I can't overemphasize. There is a notion that I speak to internally that says, have you flipped the bit around site resilience? Do you believe in your solution? If you don't believe in your solution, the first question you will ask when there's one of these events is, when is it going to be fixed? My experience is every estimate I've gotten in the service about when something was going to be fixed is wrong, particularly the first one. So our decision logic is 100% simple. If there's a 5% dip in terms of client availability of the service for a given rack or site, we fail over. We don't ask what's wrong, we fail over. We believe in our solution enough, and we know we can reverse it if it is the wrong answer, that we're going to fail over, because that is the fastest way to restore service. Don't try to figure out what the cause is. You have a dip, fail over. Believe in your solution. That will get your service recovered the fastest. Do the exercises enough to believe in your service. Make the automation be good enough that it is reliable and repeatable. Those things will make you successful in this space. If you continue to ask when is it going to be repaired, you will have longer and longer outages that will cause more and more pain. And with that, please come to the expert session. Sorry, I'm 3 minutes late. Thank you. Thank you. Did I do okay?